Welcome back. In this video, I want to solve a problem where we are going to calculate the atomic mass of chlorine based on its isotopes. So chlorine has two naturally occurring isotopes, chlorine-35 and chlorine-37. Now, on the periodic table, the value listed as the atomic mass, as I mentioned in the last video, is a weighted average. So we need to calculate this value from these values. Now there's a simple formula, and the formula is, the atomic mass will be equal to the sum, so Greek symbol here, the sum of the decimal fraction of this isotope times its mass. That sounds kind of complicated. It really isn't. We want to take all the isotopes and we're going to add them together. But before we just add masses together, we need to multiply our mass by our fraction. And that should make sense. Well, first off, let's talk about what these numbers are. So for these two isotopes, we can actually calculate how heavy they are, their mass. So chlorine-35 is actually 34.97, so very close to 35. Same with chlorine-37, it's actually 36.97. We see that the final average is about 35. So it's a little closer to this number than to that number. And that should make sense since out of all the chlorine atoms, 75% of them are chlorine-35s, and only about 25% are chlorine-37s. So it makes sense that when we take the average, since there's more chlorine-35s, our mass is going to be closer to 35 than 37 or 36. So what we do is we take our mass, 34.97, and we multiply it by the decimal fraction, which is just moving the decimal place over to 0.7577. I'll show you another trick you can do where you don't really have to worry. All we're doing is dividing by 100 here. So for the next isotope, we put that here. It's going to be the mass, again, 36.97, times the abundance. And you can either press 2423 and the percent key on your calculator, or you can divide this number by 100. In either case, you'll end up moving the decimal over. So this number will look like this, 0.2423. But if there were three isotopes, then we would just add another set, and that's what this sum means. It just means we're going to take the mass here plus the mass of this isotope plus the mass of another isotope if there happened to be one. So if we do this calculation, we actually get out 35.45. So yeah, that's how you do it. Remember, you want to use the decimal fraction, so not the percent. Now there's another way that this question could be asked. You might be asked to find what the percent is, the natural abundance of an isotope. Since we know this number, we can use that as the atomic mass and actually solve for a variable in here. So the next video will show